So we're doing some algebra. This is going to harken back to algebra word problems, basically. Make sure you're still comfortable with those. So we're supposed to write the algebra expression. Let's do part A there. Cost. Here's what I'm reading right here. The cost of having a plumber spend H hours at your house if it's $20 for coming and $30 per hour for labor. $20 for coming, $30 per hour for labor. So if that's, let me give you a chance. Can you write a formula using H? Something like 7H plus 3 or, something like that. Can you write a formula? Let me give you a second. See if you can write a formula using those ideas and H. What's the formula? It's not 7H plus 3. What's the formula? It's $20 for coming. The plumber to come out to your house is $20, and it's $30 per hour, H hours at your house. What's the formula for what it's going to cost? 20 plus 30H. Yeah, that's right. Is that making sense? Is that good? So like if the plumber was at your house for 3 hours, wouldn't it be $20 for coming plus 30 times 3, for example? Right? If H was 3 hours at your house to fix something. Is that good? Does that make sense? So it's 20 plus 30H. So the 20 does not have the variable because that's just a fixed charge. We'll call that a fixed charge. And the 30 times the variable because that'll vary, right? It's 30 per hour. Is that good? Remember that from your algebra days? All right. Were your algebra days good days? Were those happy days? Sorry, I'm just joking around. All right. The amount of money in cents in a jar, D dimes, and you got some nickels and quarters. 6 times as many nickels as dimes, and 2 times as many quarters as nickels. That's confusing. Let me rewrite it over here. So I'm going to write 1B. What are the key facts? D dimes. D dimes. And then it says 6 times as many nickels as dimes. 6 times as many nickels as dimes, and 2 times as many quarters as nickels. 2 times as many quarters as nickels. Okay. So let's start off. Can you write a formula? So we already got the one for D. D is dimes. We got that. Now, can you write a nickel formula? Let's start with that. So let me give you a second. Write a nickel formula. All right. So what's the nickel formula? 6 times as many nickels. It's just 6D. We good? You know what helps me? If you're reading that and you're going, I thought maybe that, but I wasn't 100% sure. I've noticed I think way better, and I'm way more sure of myself if it's numbers. You know what I mean? So if this was a test, like it will be in a week, and you had a question like this, here's what I learned to do, which helped me a lot, especially in gaining confidence. Because, letters can be weird. They just don't feel right. They feel strange. I would go, well, I don't know. I think that, but what if it was 10? Instead of D, I learned to just pop in, usually a 10. I don't care what the number is, just boom, 10. What if there were 10 dimes, and then somebody said, hey, I got 6 times as many nickels as dimes? Would I be able to figure out how many? If I got 10 dimes, 6 times as many nickels. Well, yeah, I'd just go 6 times 10. 60, right? And then I think, okay, so whatever I did with the 10, do with the D. Because the 10 was just a number I imagined D was. Oh, yeah, it is just 6D. And I had a lot more confidence. Does that make sense? We just think better with numbers, don't we, than we do with letters. So if you're ever reading some weird letter thing, you're just not sure, put in a 10. Think what you would do with a 10, then do the same thing with the letter, the D. All right, so the nickels is 6D. Now, let's try the quarters formula. Let me give you a second. Try the same thing. If you're not sure. All right, what's it going to be? It says, what does it say? It says 2 times as many quarters as nickels. So 2 times, we're going to double something, right? What are we going to double? Yeah, the nickels formula. The 6D. It's not saying twice as many quarters as dimes. Then that'd be 2D. It's saying twice as many quarters as nickels. Twice the nickel formula. Which ends up just becoming 12D, huh? Does that make sense? We see how we built that up? So the D is dimes. Then the nickels is 6 times as many. And then the quarters is twice that. Twice 6D, so 12D. Okay, now, that's just the amount of dimes, nickels, and quarters. We want to get the monetary value. Like how much money they're worth. Right? So if I have 3 quarters, how much money are they worth? Yeah, 3 times 0.25, 75 cents, huh? So you got to multiply them by their monetary worth now, don't you? So I'm going to take the dimes, and so it's D dimes, 6D nickels, and 12D, this is dimes, nickels, and quarters. And so if I want to figure out the total monetary worth, because that's what they asked me, didn't they? They said the amount of money. They want to know like how much total money's in the jar. So I'm going to need to multiply each of these. So what am I going to multiply the D by? This dimes here. What is each dime worth? 0.10. You can put the front or the back. The order doesn't matter. 0.10D or whatever. And then the nickels, 0.05. Careful, don't put 0.5 there, right? I've seen that mistake a lot over the years. It's 0.05, right? Nickels are 5 cents. And the quarters, 0.25. And then we have to add those up. Is this good so far? See how we're building this is a long problem. This is just part B. So and now we can't leave it that way because why? We got to combine like terms. So this is 0.10D. I'm just going to put the number in the front. This is 6 times 0.05. Just use your calculator. It's going to be 0.30D or 0.30D, either one, plus 12 times that 12 quarters. How much is 12 quarters? $3, right? So it's 3.00D or 3D. Is that good? Add those all up. You're going to get 3.40D. See how I just added like terms there? 3.40D. That's all we can do. I don't know how many dimes. They never actually told me how many dimes. They just said it's D, whatever that is, you know. So from that information, so I was able to do the whole thing step by step, figure out how many nickels, how many quarters, and then multiply those by the money, combine all the like terms. When all is said and done, 3.40D is the total number, is the total amount of money. So if I just know what dimes, how many dimes, now I can figure out the total monetary worth of the whole jar. Is that good? Is that okay? Questions? Yeah.
I'm going to say the answer is 340D.
Are you saying I'm wrong? Carolina, I'm just really offended. I don't know. Let's go back here. Express the amount of money. Oh, yeah. There's a crucial little word I didn't notice. Do you see it? Yeah, they want it in cents. Yeah, thanks. I was testing you. Good job, Carolina. So they're supposed to all be in cents. So that means 340D. That's in cents now instead of dollars. Right? $3.40 is 340 cents. Right? With the D there. Thank you. That was tricky of them to suddenly go to cents like that. Tricked me. Good. Go on to part C. We good there? On we go. Part C. Part C says the sum of 3 consecutive integers if the greatest one is x. Okay, let's talk about that. That one's a little more complex. So 3 consecutive integers. 3 consecutive integers. And so what does it mean to be 3? What does consecutive mean? What do they mean by that? 3 consecutive integers. Means in a row, right? Consecutive, in a row. Like if a baseball team or football team wins consecutive titles, it's in a row, right? So 3 numbers in a row. It could be like 17, 18, 19, or 23, 24, 25, whatever. So it's 3 numbers in a row. Okay, let me write them. Let me just make 82, 83. I'm just making stuff up. I don't know what they are. 3 numbers in a row. So that's the idea. Okay, so what did they say? They said the greatest one is X. So let's go back. So the greatest is X. So they're just giving me a variable, right? It's like they just gave it a name. That's all a variable is, right? Is a name, like naming your dog. Hey, you're Rover now. I'm going to call you Rover. That's all we're doing. We're saying the greatest one, we're going to call him X. So notice what I'm doing to make this easier. I'm picking real life numbers. I just think better with real life numbers. It's going to be like saying, all right, this guy, he's X. He's the biggest one. See why I picked the biggest one in the 3? Because they said the biggest one's X. If that's the case, then what's the formula for the one right before him? X minus 1, huh? It's 1 less than X. And what's the formula for the one right before that? X minus 2. You just keep backing up 1, huh? If the greatest one's X, and there are 3 in a row, then the one back is X minus 1, 2 back is X minus 2, huh? Okay, and what do they want me to do with these? Don't they want me to add them? Sum, yeah. See, it says sum, so that means add them, right? So the sum, if you add these up, I'll just add them vertically here. If you just add them up, 1x, 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 like terms, right? 3x, minus 2, minus 1, minus 3. There's our answer. Is that good? 3 numbers in a row. 3 consecutive integers. Where the biggest one is x. Questions on that? That good? Here we go. So there's forget what it starts, and it's not very good. The initial amount of this bacteria, wasn't it Q, and it triples every 10 seconds. That's frightening. Triples every 10 seconds. And how many after n minutes? Isn't that what they said? So it starts at Q, triples every 10 seconds, after n minutes. Yeah. So after n minutes, it starts at Q, triples every 10 seconds. Okay. So they want me to write some kind of a formula. It's kind of a weird one. And they gave me a hint, said your formula has to have Q and N. It's going to be like 7Q minus 3N, or something like that. Some kind of QN formula for the number of bacteria after n minutes. So the number of bacteria after n minutes, what's it going to be? What do we do with the Q first off? How about we start there? What do we do with the Q? Here, let's do this. Because this is a hard one. This is a pretty tough one. How about if we just make that 7, make this 8? I'm just picking random numbers. Remember what I suggested you do? If this was on a test, you were reading this, and you're like, I don't know, this is confusing. My big suggestion would be just pick a number for each of those letters, because you're going to think way better with numbers than you do with letters. So let me give you a chance to think now. Then be asking, if n is 8, they're saying, how many bacteria after 8 minutes? So figure out, it started at 7 bacteria initially. It triples every 10 seconds. How many bacteria after 8 minutes? Let me give you a second. So what would I do with it? So if they started at 7, what would I do with the 7? Figure out the number of bacteria. So it's going to start at 7, and it's going to triple every 10 seconds. How many after 8 minutes? What would I do? No ideas?
Would you have to add it to like the amount?
I think so. Yeah, start with 7. Yeah. Because it's going to start out with 7, then we're going to have to add some more, right? It's going to triple every 10 seconds. It starts at 7. Well, here, let me go slow. Let's say we start with 7. Certainly that's our number. How much is it going to be 10 seconds later? Well, times 3, 21, right? Then what's going to happen 10 seconds after that? It's going to triple again. Then 10 seconds later, whoops, not 13. It's going to triple again. And then 10 seconds, whoop, I keep messing this up. Then 10 seconds later, it's going to triple again. And then 10 seconds later, it's going to triple again. And then 10 seconds later. So that's a minute, isn't it? That's 60 seconds. So I did 60 seconds, and I have what? 6 3s. It's going to triple, meaning it's going to multiply by 3 every 10 seconds. So what is that? 7 times 3 to the 6th, isn't it? That's only 1 minute. Right? That's 60 seconds. And we're supposed to go for 8 minutes? Oh, let me slow down there for a minute. Are you tracking with me so far? So we start at 7. I just picked that right. I said, hey, suppose Q is 7, just to get us thinking. Start at 7, triple it every 10 seconds. So that's 3 to the 6th. So that's 1 minute. Okay? And then, so what's going to happen for the next minute? Well, triple it. 3 to the 6th. Again, Because every 10 seconds it just keeps tripling. See why this is scary? These are big numbers. Anyway, so far so good. That would be after 2 minutes, right? You just multiply by 3 6 times, Because every 10 seconds. Okay, that's after 2 minutes. Now we're supposed to. So I don't know if I'm here. Let me go to a new screen. So after 1 minute, it's 7 times 3 to the 6th. After 2 minutes, it's what we had after 1 minute, and then another 3 to the 6th, right? You get that other 3 to the 6th this is all multiplying, It's growing and growing and growing. After 3 minutes, it would be 7, 3 to the 6th, 3 to the 6th, 3 to the 6th. You get the idea, So after, let's go down, 8 minutes, what are we going to have? 7 and 3 to the 6th, a whole bunch of 3 to the 6s. How many of them? 8 of them. 1 for each minute, right? So is there a way we can use like an algebra rule? That's 3 to the 6th times 8, You with me on that? Right? Because you'd multiply by 3 6 times for every minute, 8 minutes. So 48 multiplies by 3. Is that good? You see that little formula we just came up with? And now we that's going to be the number. So the number of bacteria. So now let's go back. What was the 7? That was Q. So that's Q. And 3 was just the tripling. 6 was just for a minute. Times, and then what was the 8? The 8 was the number of minutes. That's our N. There's our formula. Q times 3 to the 6N power. See how I walked through that? Just thinking about what would happen there? Questions on that one? Caroline, is that how they have that one? Good. Let me know if some of these are different. I'm missing something. Does that make sense on that? Questions I can answer? I know these aren't easy. A lot of times when I was hard things like this in math science class, I would not get it the first time, look back again. So I encourage you, look back again, think about it again, it'll sink deeper. Number 1, part E. T hours ago, the temperature T hours ago, if the present temperature is 50 and each hour it drops by 6 degrees. So the present temperature is 50 and each hour it drops by 6 degrees. So present temperature is 50 degrees Fahrenheit. And each hour drops by 6. Each hour drops by 6 degrees. What was the temp? What did they say? T hours ago. T hours ago. Let me, what am I going to suggest? That's you. What am I going to suggest? What's always my game plan? If it's confusing with the letters, put in a number. Make that a 10. That's my only letter, right? Pretend that was 10. Pretend they said, hey, 10 hours ago, what was the temperature? 10 hours ago. What was the temperature? Let me let you figure that out for a second. 10 hours ago. Yeah, would you add? If it's 50 now, it's been going down 6 every hour. What was it 1 hour ago? How about that? Let's just start there. 1 hour, not hours, 1 hour ago. What was the temp 1 hour ago? It must have been 56, huh? Because it's going down 6, right? It's dropping by 6 every hour. So 1 hour ago must have been 56. Right? Must have been hotter. 2 hours ago, add 6 twice, whatever that is, right? Take the original 50, add 6 twice, because it's dropped by 6 twice in the last hours, etc. Yeah, so Jose's got it, right? So 10, Jesus has got it. Jose probably had it too. 10 hours ago, it's 50 plus 6 times 10. Does that make sense? If that thinking is correct that Jesus stated, right? It was hot 10 hours ago. So what do we do? 50 plus 6, and what was the 10? That was my T. 50 plus 6T. See how you get the answer with a number you made up, and then you put back in the letter. Does that formula make sense? Can I just add those together and make that 56T? Just simplify it? Is that right? No. Only if the 50 had a T could you add them as like terms. If the just plain number, you remember from algebra, they have to stay separate. Okay. Let's keep going. We got to finish up number 1 here. Where are we? Got lost. There. F. Powell's total earnings after 3 years. If the first year of his salary was S dollars, and the second year it was 2,500 higher, and the third year it was twice as much as the first year. All right, this should be easy. First year was S. Second year, 2,500 higher. What am I going to do with 2,500 higher? Add, S, add 2,500, good. Third year, twice as much as the first year. 2 times S, 2 times the first year, huh? We good? And what do they, okay, so there they are. What do they want me to do with all of them? Total earnings after all 3 years. They want to add up all 3 years. Powell's just saving all his money. 3 years. So, what's going to be the total of all those? So we can just add them vertically. Right? 1S, 1S, 2S, 4S, plus 2,500. S plus 2,500. We good? That making sense? Okay, one more. G. So I'll go to the sum of 3 consecutive even. So we're doing the 3 numbers in a row thing again, but this time the only difference now is they're even. So that'd be like, 22, 24, 26, for example. Let me back it up. 22, 24, 26. So this time it's not just 3 in a row, it's 3 even in a row. The greatest one is X. So again, that's the bottom one, is X. So what's the formula for the one right before? X take away 2, right? Because it's 2 lower, right? And what's the one formula for this one? X minus 4, right? Because the first one is 4 lower than the greatest one, isn't it? And then they want the sum. The total. They said the sum total. So that'd be 1x, 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 3x, minus 4, minus 2, minus 6. There's the formula for the total. Good there? All right, I'm going to move on if you're good. I know I'm going fairly fast. If the number of professors in a college is P, and the number of students S, and there are 13 times as many students as professors, write an algebraic equation that shows the relationship. So how do we write that? P is professors, S is students, 13 times as many students as professors. P equals 13S. Is that right? That good? Carolina, is that good? I'm sorry, I know I'm just bugging you. You don't have to answer. But everybody else does. What do you think? Is that true? What you could do? Again, if you're looking at that, you go, maybe, I'm not sure. You want confidence, don't you? Especially on a test, when it's a word problem, grades in the line. You want to be sure. What can help you be sure? What do I keep saying will help you be sure in a word problem? Real life numbers. Real life numbers. So what I would do, this is what I learned to do to help me so much in word problem kind of things, is I would make it real for myself. And I would make it simple real. Like, not hard, but just make it as easy. And I tell you, wait a minute, is that right? I'm not sure. Let me imagine there was only one professor. I mean, that's as simple as you can get, right? What if there was just one professor at this college? How many students would there be, according to what they're saying there? 13, right? There's 13 students for every professor, right? So if there was only, or let's do 2. How about if there's 2 professors? If there was only 2 professors, there would have to be 2 times 13, 26 students. Is that what this equation says? If P was 2, then the number of students would be 26. Does 2 equal 13 times 26? Not even close. This equation's wrong. I've got it backwards. Do you see that? See how we know? They're supposed to be equal. An equation means equality, right? But now what if we switch it? Is it good? Let's try the switcheroo. So if we put S out here and P over there, is that right? Well, we said if there were 2 professors, there would be 26 students. Is that does the equation make that equal? Yeah, that's the correct way. Do you see that? See how I became sure? It's S equals 13P. I know it's confusing, or I've seen over the years that this is confusing for students because it says 13 times students. You kind of want to put the 13 next to the S. It almost seems that way from the word order, 13S. But I tried that and that wasn't right. So this is right. And the way I'm sure is I'm putting in actual numbers. I'm like, okay, well, if there were 2 professors, there'd have to be 26 students. So Professor 2, yeah, that is equal. That's the right equality statement I have. That's the right equation. Does that make sense how to do that and test it and be sure? So that's what they want on that one. Let's try number 3. G is the number of girls. B is the number of boys. 11 more girls than boys. Can you write an equation? Write some kind of girl-boy equation. $11 more girls. Girls at 11 is boys. Is that right? Let's test it out. So when you read the words, it kind of sounds like that. Turns out it's not. That's not right. But you want to be sure, right? You don't want to be guessing on a test. So how would you be sure? Well, for example, if there was, what are they saying? There's 11 more girls. So if there were 10 boys, there should be 21 girls, for example, right? That won't work. 21 plus 11 doesn't equal 10. So I've got it backwards. Switch it. Put the boys over here, the girls over there. And now if there's, what did I say? If there's 11 more girls, so if there's 10 boys, there should be 21 girls. Yeah, that's working, huh? See how that's right? You can put the G over on this side if you want. It's the same thing. It doesn't matter, which way you do it. As long as the B has got the plus 11 next to it and the G's alone. Right side, left side doesn't matter. Right? That'd be like if I said, A equals B or B equals A. It doesn't matter. It doesn't matter which side you put stuff on. Right? We good there? Does that make sense? All is good? All right. Relating the variables described in each of the following situations. The pay for T hours if you're paid $7 an hour. So if you're paid $7 every hour and you work for T hours, how much are you going to get? What's your pay? $7 an hour for T hours? Just 7 times T, huh? That good? Next one, part B. If 14 for the first hour and 9 for each additional hour. That's a little more tricky. So let's come down here for part B. It's 14 for the first hour and 9 for each additional hour. So if you work for T hours, what will be the pay? Your pay will be... Now, let me give you a second. What am I going to suggest? This one's harder. Be careful. This one can trick you. So what am I going to suggest you do? Put in a number. How about if T is 10 hours? Just literally do it. Figure out literally how much. But again, don't just figure it all out and go, it's 73. Because that won't, or whatever, I don't know if it's 73. But that won't help you at all to just write down the final answer. Don't do that. That's not what I mean when I say figure out 10 hours. I mean show. I would take 14 minus 2 times 9, whatever. Show the steps you would do. That's what you need to see, right? Not the final answer. Nobody cares about the final answer. Because 10 is just made up anyway, Show the steps you would do if somebody said, I worked 10 hours, and they're going to pay me 14 for the first hour, right? 14 for the first hour, and 9 for each additional hour. What would you actually literally do to figure that out? Write that down, and then backtrack, and when you're all done, put the T where it needs to go. The T is representing 10, right? What are we doing? We have any good thoughts? So what would we do for 10 hours? Let's talk about the 10 hours. What would you do for 10 hours? Somebody said, you're getting 14 for the first hour, 9 for each additional hour. You worked for 10 hours. How would we figure out the money? What would we do first? Put 14? Yeah, because you get 14 for that first hour. Plus, then what? What is it?
Then we have 9 hours left.
9 hours left.
And
Times
then
$9 per hour. Right? Isn't that what I would do for the, right? I would say 14 for the first hour, 9 hours left, and those are each $9. Right? So now let's think back about the T. So where I don't even see the T. T was 10. Where's the 10?
subtract 1.
It's right there. It's T minus 1, huh? Right? It's 10 minus 1. It's how we got the 9, isn't it? Didn't we say, okay, 14 for the first hour and 9 hours left? I mean, what do you mean left? Well, 10 hours total, subtract 1. Didn't we take the total hours, like the T, and subtract 1? So well, there's 9 other hours. So that would be T minus 1. Right there. Do you see that? So the formula is really 14 plus T minus 1 times 9. Huh? Everybody see that? Because you get 14 for the first hour, and then you have T minus 1 hours left. That good? And now, we can't leave it that way. They want you to gather. I think they want you to gather like terms, don't they? Carolina, I'm counting on you. You can't leave it this way, right? They want you to gather like terms. I can go look it up. That's good. We're done. Does that make sense? Everybody see how we did that? So again, let's go back one more time. So if you worked 10 hours, and you get 14 for the first hour, 9 for each additional, you get 14 for the first hour, and then the other 9 hours, which is what? The total amount you worked, take away that first hour. That's where I get the T minus 1. You'll get $9 for each of those hours. Good. So see how using a real life number helps? You think better with real life numbers? Try that with word problems. Teach kids to do that. Real life numbers. We think better and then just backtrack to the letters. Okay. So yeah, do you remember there's like a little bit of algebra here? That's what this last bit of the course is. It's just kind of a quick little review of some algebra that you might teach in the elementary intermediate school. So how do we solve for x there? Do you remember solving for x? It's like the equal sign's like a wall. I always, left side, right side. Sometimes that helps people focus, left side, right side. X is saying I want to be alone. The left side equals the right side. What do you do when you have x on opposite sides of the wall of the equal sign? Yeah, just get them on one side, huh? You get rid of one of them. It doesn't really matter. Like I'll just say add x. That'll get rid of that one, huh? And whenever you do to one side, you have no choice. Always got to keep the balance, huh? If they were equal before, you treat them the same, they got to be equal after. That's the principle of equality, as you know. So these cancel over there. 1x and 1x. 2x. Get to there. So now we got the x's on one side. That's good. That's a good first step. Next, x is trying to get alone. We want to get x all by itself. That's our goal. Put that at the bottom. X is saying, I want to be alone. I want to be alone. Get rid of this 2. Get rid of that root 2. I want to be alone, right? That's the goal. So what do we do first? Subtract the root 2 from both sides. Gonzo. Right? And that'll be 2x. Now what's 6 root 2 minus root 2? Do the root 2's just drop to 6? Yeah, good. You know better than that, I hope? That was craziness, what I just did. Yeah, you just, it's like terms, and you imagine an invisible 1 here. It's 6 roots of 2 minus 1 root of 2 is 5 roots of 2. Remember that? Remember with roots? Roots, in the world of algebra, roots you treat just like you would an x, huh? It's like 6x minus x. 5x, right? 6 roots of 2 minus another root of 2 is 5 roots of 2. Last step to get x alone. Okay, divide by the 2. Boom. 5 root 2 over 2. That's the answer for x. On that one. Is that good? Let's do one more. Oh, it's got fractions. 4/3 x minus 3. We're not gonna make it, are we? Ooh, this is a long section. All right, let's stop there, I guess.